Let's we did this example in your notes here. I'm going to draw a right triangle. Let's label it A, B, C. It has side lengths of 16, 30, and 34. We're asked to find a few different trig ratios.
The angle.
Sine of A, cosine of A, and the tangent of A, as well as the sine of C, cosine of C, and the tangent of C. Trig ratios are built from the acute angles in a right triangle. What does acute mean? Smaller than what? Smaller than 90. So B would be our right angle. Angle B is our right angle. A and C are the two acute angles in a right triangle. Let's find the sine, cosine, and tangent of the acute angle A, as well as the acute angle C. Angle A is kind of our reference point here. Let me label angle A for you.
And a triangle with one right angle.
There's one right angle, that means the other two have to be less than 90. Every right triangle has one right angle and two acute angles.
So we can have a 1 degree 80.
The other one would be 79. I'm sorry, 89, pardon me. From angle A, what's the hypotenuse? Which length is the hypotenuse length? Which is how long though?
34.
All right, let's label that hypotenuse.
No.
There are two legs, the opposite leg and the adjacent leg. Which one is the opposite leg? The 16 or the 30? Which one's the opposite leg? For angle A, yes.
Oh, 30.
30. If angle A is on top, the opposite leg has to be the leg length on bottom of the triangle. Adjacent. Adjacent means next to, kind of like my room is next to Mr. Miller's room. We share this common wall. It's right next to mine. Which side length is the adjacent leg to angle A?
BC.
Which is how long? What's the adjacent leg length? 16. Well, SOHCAHTOA is going to tell us which trig ratios go with each of these different sine, cosine, tangent values. The sine of A, sine is opposite leg divided by hypotenuse. So opposite leg 30, hypotenuse length 34. 30 over 34. What does that reduce down to as a fraction, please? Keep it as a fraction now.
1/4.
15 over 17.
15 over 17?
Yeah, that's right.
Sounds reasonable to me.
Cool.
Divide everything by 2. Cosine of A. Cosine is adjacent divided by hypotenuse. As I've labeled them here, adjacent would be 16. Hypotenuse is 34. Those are still both even. What does that reduce down to?
8 over something.
8 over something. That would be
18
correct.
over 17 again.
8, 7, 17.
I mean 17 again. 17 still down.
All right, tangents. You guys do tangents.
That's the bottom
What
number
divided by what?
17 again.
Opposite divided by
19.
Right? So what divided by what? Say again, Ashton. 30 over 16. Opposite leg is 30 from angle A. The adjacent leg would be 16 from angle A. 30 16ths, still both even.
8 over 15.
15 over 8, I believe, as I divide them both by 2.
Nice.
We've got the trig ratios for angle A put together. Now we're going to do the same thing. Sine, cosine, tangent for angle C. Let me reframe this a little bit because now I'm going to use angle C as the acute angle of reference.
Change the adjacent leg to the opposite leg.
All right, don't I have to switch these around now?
Yeah.
Is the opposite leg still the opposite leg for angle C?
No.
No, it's the
Adjacent.
adjacent
It's
leg.
right next to it.
It's right next to it. How about the 16? It's no longer the adjacent leg, it's the
opposite.
It's the opposite. It's on the other side. Angle C is on the right, 16 is on the left. It's opposite on the other side of the triangle. The hypotenuse, is it still the hypotenuse?
Yes.
It can't change because it's the longest side of all three. It's opposite the right angle. As I've relabeled everything here, now let's define these three trig ratios for sine, cosine, tangent of angle C. Sine C would be what over what?
16 over 30.
over 50.
Opposite over hypotenuse. Remember your SOHCAHTOAs. Sine is opposites over hypotenuse. So 16 over 34. We've reduced that down to 8/17, right? Cosine of C. Cosine will be adjacent over hypotenuse. So adjacent 30, hypotenuse 34.
15%. No, that'd be 15 over 17.
I'm just dividing each of these by 2 as I reduce them. Tangent of C.
The opposite over adjacent.
So 16 over 30. That's a new one. What does that reduce down to?
15H.
All the way around, bud.
8, 15.
8/15. 16 and 30 divide both by 2. That's 8 and 15.
Yeah.
Okay. Look at those 6 values. Does anything stand out to you that might be noteworthy for us to make mention of?
It's the same thing as C.
They're close to the same thing.
C is basically the same thing as angle A for tangent.
The cosine of A and the sine of C are the same, aren't they? The sine of A and the cosine of C are the same thing as well. Here is a true statement.
Tangents flip.
The sine of an angle, let's call it theta. This is the Greek letter theta. The sine of some angle, call it theta, is equal to cosine of 90 degrees minus theta. The sine of one acute angle is equal to cosine of the other acute angle. The other acute angle would have measure of 90 degrees minus the initial angle. The sine and cosine flip. The sine of one acute angle is the same as cosine of the other acute angle, is what I'm trying to say. The sine of A is the same thing as the cosine of C. The sine of A is the same thing as the cosine of C. The sine of one acute angle is the same as cosine of the other acute angle. If our first acute angle has a measure of, let's call it theta, the other acute angle measure would be 90 degrees minus the other acute angle measure, theta. There you go. If this is 50, what does A have to be for its measure?
That's a
40.
40.
How'd you get 40?
Because 90 minus whatever that Greek letter is. It's like 50.
T theta.
And it,
They all have to add up to how many degrees in a triangle?
180.
Nine.
So then
half
if
of
you
the hypotenuse.
I already spent 90 here, leaving me 90 left over for the other 2, right?
do,
So if one of them is 50, the other is the difference of 90 and 50. What would this be equal to? The cosine of theta, the cosine of our first angle, is the same as the sine of the other acute angle. There's a couple of general relationships for the sines and cosines of the 2 acute angles in a right triangle. The sine of one is the cosine of the other acute angle. The cosine of one of the acute angles is the sine of the other. The 2 tangents are just reciprocals. They flip. All right, guys, we've got about 15 minutes left, like I promised, some time in class to work. If you want to spend some time here working on this practice handout, it's a quick practice on getting trig ratios built for different right triangles. You have a right triangle with different side lengths given, and you're asked to find, for example, on number 1, the tangent of angle Z. What should you probably write on the top?
Grenade.
Well, beside that, thank you, Parker. What else should you probably write? SOHCAHTOA. Everything else is based off of SOHCAHTOA. The rest of this unit is going to be based off of SOHCAHTOA. Nothing else, remember that. When's this test, Michael?
Yeah.
Probably next week. End of next week, yeah. Yeah, go ahead. If you want to spend your time working on that practice document or on con, like you said, go right ahead.
Can you show like